Hi, all. Welcome to the Startup Recitation. You may notice my background is different and my connection is marginal. I'm at the Pilchuck studio outside Seattle, which is the leading glass retreat in America. And I'm the scientist in residence, and we're doing a workshop on technology for glass making. So my connection may be marginal, but hopefully good enough. And recording is working. Good. So this is the startup recitation. It's going to be 7 minutes a topic, loosely in order from early to mature. And the goal of the session is both to show the startups, but more than that, to meet the people and tell the stories of the journeys of how people who haven't done this before do this and how you might be able to. Uh, so with that, we're going to start off with Vaneza. Go ahead, Vaneza.
Thank you, Neil. Good morning, everybody. My name is Vanessa. I am a Fab Academy alumni 2014. That means this year, if 10 years that I finished and I graduated in Fab Academy. And it means this project is part of my Fab Academy. And the startup that I created is part of Fab Academy as a concept, as a philosophy, and as a community. And the project that actually we are working in our startup names the carpentry ecosystem. After the COVID time, we started to connect other Fab Labs digitally to create a community and integrate artisans in wood, makers, woodworkers, and designers in our platform to integrate different practical techniques and traditional techniques with digital fabrication and create a new business model in our platform. The idea is create a network with expert carpenters and connect all of those people with laboratories, with Fab Labs. And in 2022, I participated in Fab All-In program in the first versions, and I developed this idea. It was an idea for many years, and I developed this idea in Fab All-In program. And I remember I received a lot of information about how to integrate different cultures, different techniques, and different practices in woodworking and design and carpenters. And the idea started in Peru, in my country, and we started working with my grandfather in 2024, in 2014, sorry. And then I remember the project started mixing all of his information with our information using digital fabrication. I think the startup that we created together in that moment was the fundamentals about how to promote carpentry and woodworking in this kind of era. My grandfather Panchito is for the very long time represent for us the other era of makers. So now we are digital makers, and now we have different machines. The relationship between man and machines is always part of our activities. So my grandfather told me how to use traditional machines, and I taught him how to use digital machines. So this is part of our fundamentals in iFurniture as a startup. And now this is the best part to promote the fundamental about the carpentry ecosystem. After this part, we invited some carpenters in Peru to use CNC machines. We started teaching classes. I remember we started promoting the router CNC as the big machine that we always using in Peru, in Fablabs, in Fablab Peru, and then in Fablab iFurniture, because we created our space. And then we received the first fund in the government, in the Minister of Production. We received a fund for about $15,000 to create our company, our startup. In that moment, the most important thing is to create processes with digital fabrication, a business and e-commerce in our website, and then to try to be this idea sustainable. This is the most important part. After 10 years, actually, we have a business model. This is very sustainable business model. And now we are replicating the idea in United States, because I am actually living in Virginia in USA. But now the idea is not just integrate machines and man, it's integrate everybody around the world using the network, the FabLab network, and integrate traditional techniques in other cultures with digital fabrication. So the carpentry ecosystem is a community of digital carpentry in a network, and add them to existing platform to the FabLab. So this is our idea, evolve our business model, and then work with carpenters, create programs for carpenters and designers, and integrate an ecosystem to share information, to improve their businesses, and also to create a big community and evolve our techniques. And I think this is the part of the evolution about creating classes, programs, and learn together. How we will do it, or how we are doing. First, we are connecting some Fab Labs, wood spaces, wood shops, and router CNC zones in different regions around the world. And we are talking with them if we can to make a pilot together, how they will start connected with the Fab Lab, with programs or with special classes, and how they are sharing information with Fab Labs, and then create a local communities in different areas. And after that, after we have the first carpenters in the world using digital fabrication, or having good master classes with us, our idea is transfer of those knowledge with new generations, young people, or adults that they are very interested in woodworking, design, furniture, space, architectural in woodworking, etc.
Vanessa, 1 minute warning.
Okay, the creation of these digital woodworking programs replicated the experience of Peru, because actually we're working in Peru in one school. And this is some videos about our experience with young people in Peru. We are working with people in schools, and actually we are creating programs with women designers, that they can to integrate these carpentry ecosystems, and we are creating courses and programs for everybody. So this is our proposal this year. Actually, we are working on that. And if you are interested in participate with us as a teacher, master, or maybe people who wants to participate in this experience and replicate in your Fab Lab, just keep in contact with me. Thank you very much.
Thank you, Vanessa. 7 minutes isn't enough for anyone. I'll be rushing everyone to get through. Everyone speaking welcomes follow-up. Reach out to them. You could post in the chat your contact information. Okay.
Thank you.
So let's see. Next, we go to Antoine.
Hey, hello everyone. First, let me share my screen with you. So I can go through my website. There you go. Yes. Can you see it?
Yep, good.
Yeah, okay, perfect. Sorry? Oh, well,
Sorry.
okay, so yeah, my name is Antoine Jaunard. I'm from Belgium, now based in Barcelona in Spain. Back in 2020, I participated in the Fab Academy. And just after that, I started the Domingo Club, my design studio slash startup. I'm going through my website, through our website now, because like most of we do is documented online, and it's good practice to show it, and then I can also see if something is missing while I present the project. One of our main project is we call it the Domingo fermenter. It's a fermenter device, a temperature controlled chamber that we use to grow all sorts of microorganisms. We mainly focus on mycelium right now, but we also use it to grow bacteria and yeast. So back in 2020, I turned vegan and was looking for protein alternatives and found the tempeh. So tempeh is a fermented food. We do it with like different legumes, traditionally soybeans, but we can do it with chickpea, black beans, whatever beans you have around in your local country. You ferment it using mycelium, and for that you need a controlled temperature chamber. So with my partner that was working in the VAR, the Fab Lab in Amsterdam back then, we started to make a prototype. So the first one using like Arduino, and then quickly, since the Fab Academy, I designed the first PCB, so we were able to minimize a bit the electronics and to be a bit more precise on what we were doing. And then quickly we arrived to the first design. So the first design we could share with the community. Also like to get some feedbacks on, is it working? Is it needed? How do you use it? What is the main use case you do with it? Like basically it's a chamber. You can put anything in it and you control the temperature and all the living organism can grow. And then you can do food or materials or ink or like a lot of different outputs. But us as the designer, we needed like more people to jump in the project and to see what we can do with such a tool. We joined like an acceleration program called Food Shift 2030. It's an acceleration program led by the Fab Lab Barcelona. It's a few months where we had access to the lab. And we decided to go from a prototype from the Fab Academy to a product. So we continue the design. I'm gonna go quickly. Tac. And so yeah, then we won a prize. We were seen by many people around the world, mainly the tempeh community, which is a niche but very strong community, because such a tool was missing for the tempeh makers to be able to grow a good plant protein at home. From there, we diverged between two different models, a mini and a lab. I'm gonna go through. And we decided to precise a bit more the design. So going from, we were doing everything ourselves and then starting using different services so we don't have to do everything. So working with PCBWay to produce the PCB, making a better interface so more people can interact with the design without difficulties, and make sure that we program like different mode for the fermentation. So you just have like one button to click and you go from mycelium, a bacteria, or like a certain temperature curve to make sure that all your microorganisms are happy. And so this is like the two design we have now, like the big one, the green, we call it the lab because we can do so many things in it. And the small one is more like the kitchen one. We only use like 4 petri dish in it to make tempeh, so to make the plant protein at home. Since everything is open source, so maybe just a quick talk about our business model. So first, everything is open source. You can download it like Fab Lab mentality. You download it, you make it, and you use it, and you modify, you hack it, and you participate in the project. Or if you don't have the resources, the knowledge, or the time, or the lab, you can buy it ready-made, and we make it for you. Such a business plan, such a business model works very well for us because we have many makers making the tools, but a lot of people around us are not maker and they can still buy it. We did a few workshops with different people from different communities to make sure that It is easy to fabricate. You can go to any makerspace using the CNC, connecting the electronics, and then fermenting your food. This one I will pass. And then, as I said, like different makers around the world started to make the fermenter. So we also sell only the electronic, so as a kit, so you can plug the electronic and use it in a styrofoam box or a new design, like laser cut design, or like the fermenter also inspired different Italian designer. We have been talking there, and since then they started designing another fermenter, also to promote more fermented food and plant protein around the world. Another user made another version to ferment koji, another fermented food full of flavor, and had to adapt the design to make it. Or like different interfaces, not only using the OLED screen, but the ESP Home protocol where you can see everything from an online dashboard. The main idea with the Domingo fermenter, so the first was to explore the mycelium, to explore the plant protein we can reach from the tempeh, going to the koji, the Japanese ferment, to have more flavors. You ferment rice and it becomes fucking delicious, and you can have like a lot of different flavors in your plate, and you do everything at home. And now we explore mainly the composite material, so mycelium material using wood chip and the mycelium to make objects. And I will go gently there. And so using the same tool, going from the food, maybe I can show the food. So the food, this is the food. The blocks are the tempeh. This is a workshop we did, like teaching how to make tempeh with people. And the white part here you can see is the mycelium that grows around the beans. The same technology with the mycelium and the food. And we can make blocks that are very light. These one were like sculptures just to test a bit the shapes, to test a bit the properties of the material, and to give more ideas to different people, like architects, designers. Like if you get that tool, then you can make your own composite material at home or in your lab easily.
1 minute warning.
1 minute. So this is like the product we have. This is like the type of research we do. And can I move this? And then if you want to follow like our process, you can reach us on Instagram, is Domingo Club. The website is domingoclub.com. And online, you can also get the fermenter electronic kit. So we teach you, everything is documented online. You can get the PCB, different connectors. And from there, you can start growing anything at home. Mycelium is the most exciting one, I feel.
That's great. Why is it called Domingo Club?
Domingo Club because we started a project in Spain, and now we have the Fermenters Club on the Sunday. So Sunday in Spanish is Domingo. And so every Sunday we meet and we either make devices together or we ferment food together, and we teach people how to collaborate with microorganisms. Also, when we start like such a project, like the first part is building a community to make sure that people understand the use case of what we do, and then start experimenting, and experimenting in the community is much easier than alone at home. So we try to build that safe space where people can meet and start to experiment with food. So that's
wonderful.
The Domingo Club. Yeah.
Thank you, Antoine.
Thank you.
Teddy.
It's such a beautiful website. It was wonderful.
Thank you.
Yeah. Let me share my screen. Hi guys. You guys all see this?
Yep.
Great. I'm Teddy Warner. I'm also a Fab Academy graduate, the 2021 cycle. And I've been in the AI hardware space for 6 months or so now on this project that I call Tone. It's an AI pendant. And so to start very, very high level, I may be preaching to the choir a bit here, but this is my new university knowledge. Before I was in the tone space, I was actually in the agri-tech space. My Fab Academy project was an aquaponics tank. And I stuck around in that space for probably 3 years. I did a couple iterations trying to address larger scale communities and trying to bring food closer to people so people appreciate the food that they consume, right? But then I started studying product market life cycles. And the big thing to take away from this graph is the nice S curve with the plateau at the bottom and the plateau at the top. Because if you look at the growth model for most rising technology, you see that we don't have linear or huge exponential growth. We just have a chart of nested S curves where plateaus overlap. And so I've been following this thread and ended up pivoting from agritech into AI hardware, which sounds like a huge leap. It's actually the same PCB that I initially started with. I went through ESP architecture. I think I'm on Nordic now, which is the same as the Fab Academy class. But the thread that I ended up following was the movement of technology to on person. And so we start with big mainframe computers, move to PCs, to laptops, to mobile devices, to watches, to today. And it's been a decade, and we still don't have that new piece of hardware. And so the thing that I've grown adamant about is that we need some piece of technology that no longer takes your time from the real world, but instead complements it, something that extends reality, not replaces it with a screen, right? A passive interface. So I developed Tone, which is an AI pendant. And the why now really boils down to AI has grown huge in popular culture. Its prominence is massive, and it knows a lot of things. It can tell you about astrophysics. It can tell you about PCB design for your Fab Academy final project, but it knows nothing about you. And so, we know that there's this plateau right now, and it's prime time for us to inject this new piece of hardware. And B, we know that we're missing data for AI. And so I sat down with a buddy of mine, and we said, hey, what's the best way we can equip people with a data shovel that allows them to feed AI context of their lives, right? And we wound up with this pendant. And all this pendant does is take notes after the fact. So if I'm talking with Neil and I'm like, wow, this self-replicating material or whatever Neil's working on is so fascinating, I don't want to be sitting here with my pen and paper or with my mouse and keyboard in front of me. I want to be truly trying to absorb whatever Neil's telling me. After the fact, I can think, wow, that's cool. I can click my pendant and it'll clip that conversation. And so every single interesting fact, every single to-do list, every single habit is all captured by Tone and stored in a personal vector database that's accessible by a personalized AI model, which allows you to do things like this. So Lola and Ashwin are my roommates, and I haven't seen them in a month. I've been back across the country. And so maybe I've forgotten what they like to eat. And when I go back to school, I can take out my phone and ask my personal AI model what they like to eat. If I haven't seen a friend of mine in months and maybe I forgot what we talked about last time we had coffee, I can just ask. Or I can even remember the song that I put on this morning. Really what Tone does is it captures your lived experiences, ideas, conversations, to-dos, habits. It's all tracked, stored in a personal vector database, and embedded into the best available AI model. So whether that's GPT-4o or Claude Anthropic, whatever. We're versatile. It's plug and play. We're really a data shovel company, a note-taking device, etc. And so the main value add here is if I'm starting my next creative exploit, this one's talking about a blog post, but imagine I'm doing my Fab Academy final projects and I'm trying to spitball and I'm like, whatever, on anything, any step of the project, I no longer have to sit down and scroll through my endless notes. I have all of my notes synthesized so I can remember them as if it happened 30 seconds ago. And all I have to do is ask, right? But it becomes more trivial. I can just ask what I have to do, my to-do list. It'll tell me I need to floss, I need to take out the trash, whatever. So it covers the entire span.
Teddy, 1 minute warning, and the vision is great. What is the state of the product and the company?
Yes. So we started hardware. We built this thing out over a weekend. And we've gone through 4 prototypes. We launched on Twitter. We did 250,000 on our initial waitlist impressions. We opened pre-orders recently with 1 post. We're ramping up our marketing this week. And we're going to be shipping a batch 1 of 500 units in Q4.
Great.
So here's a picture of me and my buddy, but this is the final slide. So the big interest is we built this project out It's just a fun, like, here's this idea, here's this space, here's this plateau of nested S curves in a weekend with the ESP32S3-Pico-1. And we've switched to the Nordic architecture. We've really tried to ramp up user experience, because that's the big value add here. How can we make this thing as sleek as possible to people? And so the pivot from, I guess, Fab Academy level project to company solely just becomes user outreach and truly understanding how can you make something that's beautiful, that works like a Fab Academy project, but that also is so sleek and streamlined that it can be used every day and can handle a beating, etc. Our pre-orders are open on our website along with our story. My contact info is on there. Feel free to check us out. I appreciate it.
Great example, impressive turnaround. Okay, Paul, you're next.
Hey everyone, how are you? I'm just going to share my screen here. That's really cool, I'll tell you. Can you all see my slides?
Thank you.
Yep.
Okay, great. So this is actually an interesting segue. So I'm going to be talking a little bit about startups in developing economies. So I'm with Energy Generation. We're a business incubator in West Africa. And so we have an interesting program where we work with entrepreneurs for 2 years. We have a business degree joint with basically a startup. And so the EnergyLab, which is what you all know from Fab Academy, is a department of this larger organization, Energy Generation. And we are basically the product development side. And so it's actually, this is a really good segue from what Teddy was talking about, from how do you go from a Fab Academy project to a startup, and how do you make that leap? So what our objective is we want to take an entrepreneur's idea and turn it from an idea into a business plan and an MVP. And so we've worked with over 70 entrepreneurs across 3 cohorts of 2 years each.
Paul, what is an MVP?
Minimum viable product. Thank you. Sorry. And so, yeah, so basically we've worked with over 70 entrepreneurs across 3 cohorts of 2 years. And we use the Village Capital Venture Investment Readiness and Awareness Level pathway, so the viral pathway. So Village Capital is basically an impact investing firm, and they have developed a really good incubation methodology, which I'll talk about in a second. So that's a little bit of a background about us. So here's just kind of the presentation outline. So I want to just very briefly introduce the viral pathway. And then I really want to talk about challenges that are specific to developing economies, like that, because it's a totally different problem set when you're doing a startup in a developing economy versus in a developed economy. And then through kind of our 3 or 4 years of experience working with these startups, suggest some models that have been working very well in these kinds of ecosystems. And then also I want to present some opportunities, not just for startups in developing economies, but also what the Fab Lab network can do, and what if you are a startup, what you can offer that could be of value to developing economies. So like I mentioned, we use the viral pathway, the Venture Investment Readiness Assessment level. And it's basically these kind of flagship, it shows all the milestones from starting an idea to level 9, which is your exit in sight, across these different, your team, your problem vision. But the thing I really want to point to on the right here is the type of funding that you'll receive. And when you're in a developing economy, venture capital doesn't exist as much. So you really have to rely on bootstrapping and grants for R&D and hardware. And so that's kind of the focus of this discussion, is how do you bootstrap your Fab Academy idea into a startup? And then how can you, because you're in an economy where venture capital isn't as accessible, how can you basically leverage other resources and sources of funding? So this gets into the challenges. So I mentioned there's a lack of access to venture capital. Another challenge that a lot of startups face is supply chain and logistics. So it's either time or money to get things to places. This one is very important. Customer is much more sensitive to the price point, and they lack access to credit. And so in a developed economy, someone can use their credit card and buy a $2,000 machine, or buy a paycheck's worth of something. But in a lot of these developing economies, that's not the case. People, it's an informal cash economy. And so people have to save up to buy their things. So you have to be very, very aware of that in the way that you present your business model so that people can afford to buy your product. Infrastructure can cause challenges. And then another big one is insufficient technical capacity. So you can develop something, but if there isn't the technical capacity to maintain and repair it, you won't be able to properly service your customer. So some of the suggestions that I have for the financing are, rather than trying to find venture capital, try to align yourself with development agency objectives. So the World Bank, United Nations, GIZ, all of these, and the foundations, and try to focus on solving a problem or aligning your product with a problem that they are interested in supporting. Another one is build a 6 to 12 month war chest of runway to account for cash flow funding issues. So with venture capital, the money flows fairly easily, but when you're working with foundations, sometimes things can shift, priorities can change, you run into bureaucratic problems. So really just focusing on that. For your supply chain and logistics, this is the big one. Invest in tools and production. Because the thing that's great about tools in a developing economy is if your startup fails, you still have the means of production to pivot into a new product or idea.
Paul, 1 minute warning.
Okay, sorry. So for the customer finance, be very extremely price and cost sensitive in your design. And I'm just going to go right to some business models that have worked really well. So two really ones are using a pay-per-use model. So where you own all of the equipment and you have the ability to turn it off, and then the customer pays for the use of the model or of the product. And then another one is modularization. So rather than selling someone a whole system, you sell them a solar panel, then you sell them the batteries, and you just allow them to build so you can align with their abilities to purchase. And then quickly, the opportunities for the digital fabrication, distributed manufacturing. If you are in the digital fabrication space, there is a lot of opportunity here for building machines that can be used in this distributed economy. So it's a very unique chance to solve problem sets of building the capacity for people to build their products in their local context. And that's it. Thank you.
Great. We could spend an hour on that. Thank you, Paul. So next we'll go to Daniele, Fab Academy student turned instructor turned machine builder turned entrepreneur.
All right. Can you see my screen?
Yep.
So hello everyone, thanks Neil for the introduction. As Neil mentioned, I'm a Fab Academy student from 2015, and here you can see my website. And the reason why I went to Fab Academy was because I wanted to start building something. I was just a programmer behind the desk, and my final project was a drone. But more than just a drone, Fab Academy enabled me to build whatever I wanted or whatever I liked. And the first thing I started to build after Fab Academy was this laser cutter machine. This is an open source large format laser cutter that I built in 2017. And while I was building it, by chance, somebody saw it and said, okay, I want to buy it. And then basically that was my first customer. And the different approach here was that we built the machine together with the customer. So the customer didn't just buy the machine itself just to use it, but he bought also all the knowledge and all the educational background needed to build this machine. And that was the start of my single man business company, because my sales were very low, basically only this machine as a starting point. It was a very small business. But then with the time, I started building more and more machines. So like, for example, large format 3D printers, and also, for example, small format laser cutters. And the numbers started to increase. So all the machines you see here have the same philosophy. They are open source, they come as a kit, and you can build them on your own, or we can come to you, or you come to us, and we build the machine together with all the knowledge behind it. And basically this then evolved into this new version of the laser cutter, a small one, which is now getting sold throughout the last 3 years. And at the end of the day, we spun off a bigger company, a limited liability company, which was founded in 2021. And we also got a grant from the Ministry of Defense here in Germany to develop further this kind of open source machine. So we have at the moment 10 employees. We had a revenue of almost 1 million in 2022. And we are basically building a lot of machine prototypes, and we have deployed these machines in 3 continents, 7 different countries. And basically the whole company, which you can see also on the website, InMachines.net, focuses on few products like these machines, for instance. We are also FabLab experts, so we thought of offering our expertise to create new labs, for example, to create mobile FabLabs, or to work with the supply chain. For example, we have supplied Fab Academy kits, and we are recently supplying FabLabs in Africa at the moment. So from FabLabs to FabLabs, we have been doing also teaching Fab Academy. We have been created custom machines and also created a couple of FabLabs here in Europe. And our clients are very variegate. So the mobile FabLabs were basically for a GIZ project called Tolocar, which is now deployed in Ukraine. And then other clients, here some pictures about the mobile FabLab. The other clients is the Ministry of Defense, where we have to create this set of open source machines. The set is called OpenLab Starter Kit, and these are the machines that we have to create. And these are the version 2 of the machines. We have to finish the project with the version 3. And then other clients include machine building workshops, so schools and universities here in Germany or all over Europe basically ask us to build a machine with them. So we sell these kits to them and we build together the machines. We also have been doing workshop remotely, especially this one, for example, in Ukraine, where they put together a laser cutter. And since we build this machine with standard material and easy to source parts, it's easily possible to replicate this machine everywhere. In fact, this machine was replicated in Ukraine, but we also have built 2 in US with you, Neil, in Boston. And then there were also some in Tunisia, for instance, in Africa, and so on. So we are basically having a customer base which is very diverse, and it's basically taking care of having the knowledge rather than just having the machine. So it's a completely different approach. And so we also have some products in the documentation sector, because we basically try to document our machine in a way that is as easy as possible to understand for everyone to build the machines. And recently we basically have built also a 3D version of an assembly manual, which supports like the explosion of the parts, and the user can tilt and rotate the parts freely, which can be actually one of the products that we can sell to companies on how to assemble their machines, or for example, their own products with the customers and so on. So basically what we do mainly is selling these machines you see on the screen. So if you like to have a machine that you can build yourself and it's made in the Fab Lab and for the Fab Lab, you can contact us. So in the future, after the grant from the Ministry of Defense ends, we plan to deploy some of these machines as proper products that can be sold with the CE certification, and also can be bought directly assembled and not just as a kit.
1 minute warning.
Yeah. Okay. So Neil, actually, I'm done.
Okay. Now you sort of single-handedly done the whole Fab 2.0 agenda. What's next in your roadmap?
Well, we have applied for another grant recently, which is about making open source industrial machinery. In this case, the machine will be manufactured without any machine that is in the lab. It's the opposite of the machines we do now. We want to use high-end industrial tools and manufacturing technologies to produce industrial machines, because we would like to have a footstep in the industry with some open source machines. So we applied for an extra grant to make a metal 3D printer, hard metal CNC milling machine, and fiber laser cutter machine.
Great.
So we hope this for the next 2 years. And then we have some more serious machines that can run some production.
Good. I'll reach out. There's some great use cases. Okay. Thank you, Danielle. On to Joe, who with a farmer student, Alan, created shaper tools.
Thank you. Let me find my window here. There we go. Can everybody see that?
Yep.
All good. All right. Hey, everybody. I'm Joe Hebenstreit. I'm with Shaper Tools. And you probably know us or you may know us for our handheld CNC machine, but we also make some other digital fabrication tools and the vector design software and fun stuff like that. I've been leading Shaper for about a decade now. And today I'm here to talk about when you might want to move slow and when you might want to move fast, because I know that at this stage, you hear a lot of conflicting advice, usually about going fast. So here we go. Now, I'm going to start with a bit of a rhetorical question, which is if we think about two paths to product development, this path A and path B, path A being launching a product when you feel confident that you've done your homework sufficiently, or path B, launch your MVP. And as we heard earlier, that stands for minimum viable product. Thank you, Paul. And iterate, learn, evolve as you gain new information. Which of those paths do you think is better? Okay, I can't see anybody, can't see responses, but I'm going to let you know, or I'm going to make the argument that path B is almost always better in my experience, especially when we're talking about new innovation. However, this is the important part. User trust is at stake. So you have to be very careful that if you're going to move fast and if you're building a company, that you don't do things that violate user trust. In fact, I would say that you really have to actively strive to not violate user trust. Now, I like to talk about examples or use examples to bring it to real life. Does anybody recognize this device or this company? Probably, if you're familiar or if you're taking this class, you will. So this is the Formlabs 4. And, I think, I'm not sure the exact year, but I think it was around 2012 when Form came out with their Form 1. And really, from my perspective, at least, did a good job of meeting customer expectations. And now they're around today, multiple generations in, and I think they've done a really admirable job of building up that company into obviously a, amazingly successful company. And they've done that by iterating as they've gone, learning from their customers and building as they go. So I'd say good job to Formlabs. On the other hand, is anybody familiar with this device? So this is the AI pin by Humane. I'm not here to bag on the company or anybody who's worked on it. I mean, after all, I used to work on Google Glass, so I wouldn't have any room to talk. But yeah, I'd say the way that this is coming to the market and maybe the expectations that have been set, I think that this company may have a difficult time coming back from that in terms of brand reputation. So this is an area where trust may have been violated and hard to get back. So this is all a big lead up to say, if you're starting a company, I would really encourage you to get out of the lab as soon as reasonable. You probably heard this, certainly from Neil, prototype early, prototype often. Test your products internally and aggressively, but then I really encourage you to get outside as soon as you can. And really a big takeaway for today is to know that the first time a stranger experiences your concept, that's when the real work begins. So this is really maybe something to think about as you're starting your projects. So again, I'm going to bring this to life with a real story. So this is Ilan and Alec. Ilan on the left, he was a student of Neil's, How to Make Almost Anything class. And this is about when I met Alec and Ilan. They had built this prototype of what's now Origin. This one was called Armstrong. This didn't have a Z-axis, so we moved on and built Brubeck. Brubeck is operating great. Look, we've got a happy user, Laura, internally. Everything's working fine. Cuts are great. UI is developing nicely. Alec and Alana are really intent, like now's the time. We've heard it. We need to kickstart this thing. We need to get it to the market. Let's go. This is probably the first real business decision I made when I was at Shaper, and I said, hey, before we do that, let's build 10 of these brewbacks and get them out to real users. This is where we're going to learn a lot. And I think it's an important point to slow down. And this is when our beta program began, and we got them out to woodworkers, craftspeople, kind of even trying to understand how we would market the product. And it's about this time that I met kind of wild person at a dog park. His name was Sam. Wild in that, you know, he's just kind of crazy ideas, crazy talking. I knew he's a maker type, and I wanted to get one in his hands. So he came by and picked one up. And within 30 minutes, I started getting messages back from Sam like this. I may have blown up the Z-axis. And then, you know, I'm writing back to him like, Sam, this is crazy. We haven't had any problems with the Z-axis. We've been running this for months. No problems whatsoever. Well, it turned, you know, I went over to Sam's house, and this brewback is laying in a pile of MDF dust. Turns out that dust collection wasn't important to Sam like it was to us. So this is a test case that we really hadn't considered that users would be doing. Of course, they'd hook up the backend. So this is a picture of Alon, you know, contemplating his existence for what would be about the next year as he went on to redesign, I think 7 generations of Z-axes, and made it through the other side, and, you know, all the torture testing that came with it. And I'm happy to say that we ended up shipping a much better version of this product. It's called, we shipped a code name Coltrane. A happy Alon, and knock on wood, I don't think we've had any failures in the Z-axis in all the tens of thousands of machines that we have out in the field. So my message here today is to move with urgency, but please slow down when user trust is at stake. Looking forward to seeing what you all build, and let me know how I can help.
Great, thank you, great story. Okay, next up is Marcelo, part of the Formlabs team.
Hey, can you hear me?
Yep.
It's good, cool. All right, let me share my screen. Here, this one. Actually, no, hold on, let me share this again. I have a video, let's make sure that this plays. Can you see the slides?
Yes, let's see, right now we see Formlabs.
Great. And then you see some colorful stuff?
Yes.
Cool, all right, I can't see anybody, so hope everybody sticks around to the end. So hi, my name is Marcelo Coelho. I'm head of design at Formlabs. I'm also faculty in the Department of Architecture at MIT, and I got my PhD from the Media Lab, where I got to spend a lot of time at CDA. Just a very quick thing. So when I was there, I spent a lot of time working on things like this. This is an artwork I did. It's a sandcastle, I call it, which are drawings of castles that are drawn into grains of sand using a fib and a sand. But now back to Formlabs. So Formlabs started around 13 years ago at CDA, with the goal of making 3D printing more accessible by making it both affordable but also easier to use. So this is a photo of Max and David Craner, two of the founders. Max is currently the CEO, working on some of the kind of early prototypes of our Form 1. And we have 2 core technologies. We have SLA, which is a stereolithography that uses light to harden a liquid resin, and SLS for selective laser sintering, which is a laser to fuse sort of plastic powders into functional parts. Actually, there's 2 machines in this photo. There's the printer on the left and Sift on the right, which is a machine for post-processing parts after they're printed. When we talk about printing, people think about machines or just like 3D printers, but it's more than 3D printers. It's also materials and it's also software. We have over 40 different materials today that can support a wide range of applications across product design, engineering, entertainment, medical, dental, etc. It's pretty awesome, actually. Just to give you some examples, so we have, so tough, impact-resistant materials, have biocompatible materials. We have materials that you can use for making tools for injection molding. We have silicones and rubbers, high performance, so this is ceramics, and flame retardant materials as well. And on the software, we have an entire sort of software ecosystem, all the way from Preform, which is a software tool for preparing models for printing, all the way to Fleet, which is a software tool for managing entire fleets of printers. Some of our customers have over hundreds of printers that they kind of orchestrate and have them work together. It's almost like you can think of it as really sort of entire 3D printing factories. Over this last 13 years, we've sold over 130,000 printers. By some counts, that's more professional 3D printers than any other company in history. And they have collectively, we estimate, printed over 300 million parts, which is quite a bit. And since we've started, we have grown quite a bit. So today, Formlabs has a team of over 900 people. That includes, R&D, manufacturing, marketing, sales. That's distributed all over the world. And we serve customers in over 100 different countries. So we're really a global company today. And our long-term goal is to build tools that allow anybody to bring their ideas to life. Today, we work exclusively on 3D printers, but in the future, we'll probably end up making every tool that you encounter in a shop. The new asked to talk a little bit about the sort of growing pains of scaling a startup. So I got kind of like tidbits of thoughts and advice and things that might be useful for folks. So I joined Formlabs when the company had about 100 people. I guess officially joined Formlabs. I'd say informally joined from day one, but officially joined when the company was at about 100 people. And some of the challenges that we've faced, they have changed over the years and with the growth and the size of the company. But some also are in very to scale. They have been the same challenge from day one. So early on, perhaps the first one is if you're considering doing a Kickstarter, Kickstarter is not for COGS. It's for COGS, not for funding the company. So when you're raising Kickstarter, make sure you also have funding to run the company.
Marcelo, what is COGS?
Cost of goods sold. So it's the materials and the labor it's directly used to create the product. So that doesn't include marketing and sales and your lawyer and things like that. And you're going to need those to run the company as well. And everything is going to take longer than you think. I think that's the real reason. You're going to need cash because things will take longer. So make sure that when you're starting a company, you're working on things you personally, truly believe in and you have a strong intuition about. Until you get your product market fit, when you know things are going to work on for real. And that period will take quite a bit of time, or could take quite a bit of time. The other one is a new products drive business. Launching a new product is great for marketing and it helps drive revenue as well. The important thing that we've learned over the years is to become better at predicting how long it will take to launch a product, how long it will take to develop it. Because that gives you a predictable business, give you predictable revenue, which then lets you do all kinds of other things. I wouldn't say we're great at it. We're getting better. We're progressively getting better at it. The other important lesson here too is that if you announce too early a new product and you have very long lead times, you'll miss on a lot of sales. Customers will hold back from buying something if there's a long lead time. Perhaps the biggest and most important lesson, if there's one slide you should pay attention to, it's probably this one. Hire the best possible people that you can. It sounds obvious, but it's not that obvious. When you really need to get work done and you have a candidate in front of you, but they're not quite the right person, and you'd be tempted to just hire somebody. Hiring is really hard. This is a graph of a typical hiring pipeline for one role at Formlabs. So, went over 706 people to find one candidate. It's more competitive than getting to MIT to work at Formlabs, which is a little crazy. And you need to find people that help you get a lot of work done, especially in the early stages of the company, and that are a good cultural fit. Wrong people add negative time to your company. They'll take time away from other people. And letting people go is difficult. It sucks. You don't want to do that. So make sure you find good people. And if you're successful, if you have, good product market fit, people are going to come after you. You're going to get copied. You're going to get sued. We kind of have the sort of almost like internal jokes of seeing how competitors are copying our designs every time. It's pretty fascinating to see what people choose to copy and not to copy. The thing, so as we grew, we became an international company, and managing an international team is really, really hard. So one thing that I've learned is that things like hiring and sales are better if they're done locally by local teams because they speak the language, they understand customer needs. But things like product design and engineering, we do them in Boston in sort of a more centralized way, but with global impact. To wrap up, a few final thoughts. If you need to think about this sequentially in any way, so find product market fit. This is the whatever primary goal. Once you find it, go fast. Try to grow quickly, but if you can't grow quickly, then be efficient so you can last. And as you grow, when you hire more people, we're gonna have to work hard on morale, make sure everybody's productive and happy. But nothing beats a good business. So having a good business, make sure that everything else falls into place. And stay focused. We're hiring, always hiring. So if you're looking for a place to do more of the stuff you're probably doing now, Formlabs is a good place. And if you have any questions, feel free to reach out. Thank you.
Great. I don't know if you were involved. Danielle has a question about the Kickstarter campaign, how long it took to prepare and launch it.
I don't know exactly, but I think it took about 1.5 years to get everything in place. 1.5 years to 2 years. The Fab Academy class for students involved on Wednesday is going to be about the life cycle of businesses, including that. That was very important for Formlabs. It was also important for 3D Fablite. My student Jake was an intern hired to work on the Kickstarter campaign, and he ended up essentially designing the mechanism, did much of the machine design. Yeah, if anybody has any questions about this stuff, do feel free to reach out. It's really hard to be an entrepreneur. It's very, very difficult, and we can give advice wherever possible.
Let me lead in to wrap up with that. On the, I guess I'll show this here. What I'm showing is just a list of names right now. And what that's about is, this has been a wonderful hour about entrepreneurship growing out of broadly how to make, and ranging from nascent early stage of 1 or 2 people up to 1,000 people in maturity. These are all successes. I didn't include failure. And by failure, what I really mean is not companies that failed, but companies that failed to even get out of the starting block of interests that didn't engage. And everybody in this session is a star. You're sort of like icebreakers who plowed through obstacles and made this happen. It's a high barrier. It's hard to do. I've wanted to make it easier. And I've been frustrated. In the past, I tried to pair entrepreneurs with inventors. And in the Fab Lab network, it led to a lot of frustration because the inventors felt like the entrepreneurs weren't telling them useful things. The entrepreneurs felt like the inventors weren't following their instructions. And a lot of what was happening was kind of fighting the last war, reprising what might have worked in a different setting, but didn't work in this new world. And there are well-known incubators, but traditionally have a model of you go to the incubator and you go through their pipeline, and also have a lot of assumptions like the goal is exit, not social change, improving the world. And so what all that added up to is what we've been calling distinct is Fab Academy is doing distributed education. The goal of distinct is a distributed incubator. Fab Academy brings the school to you, not online, but hands-on. We want to turn the whole network into an incubator. And so what I've been doing is this list of names with a range of backgrounds generally are people who have been very successful running up businesses and are at a life stage where they're thinking about their legacy and the future of the planet, and building a team of sort of global best practices mentors to then, in the same way, Fab Academy, which grew into Academy, teaches global leaders in digital fabrication and biotechnology and textile technology and all of the growing classes. We now want to do that for incubation. So this is a coming attraction. The last hour showed the promise. I and we believe in the network, in distributed innovation. We want to make it easier to do what you just heard in the last hour. And we'll be developing this platform for distributed global incubation. So I can't answer questions because we're still figuring out how to start in collaboration with all of you. One of the goals is come the event in Mexico to start to mature it, and this fall start to wake up this distributed incubator, leveraging the network, working together with all of the other global programs. So that's coming attraction for Distinct. And with that, this was a pleasure. What you've each done is remarkable. And I want to underscore everybody here is passionate about what they presented, and very happy to talk to you at any level for any interest in following up. So with that, I applaud all of you. Thank you for sharing your experiences and everything you're doing.
Thank you. This is lovely.
Thanks.
Thank you.
Thank you.